I'm Dan Bolton. It's such a joy to be here. I appreciate the opportunity. So behind me is a picture of the first meteorological station on Earth. It was constructed in Athens. It had a big weather vane on top of it, and it had water clocks and sundials. And for the first time, there were scribes who recorded daily what the wind direction was and where the information associated with the time of day when the wind started and such like that. They collected data. They were the first guys to really develop organized data. And it was so powerful because they could begin to be predictive. They could begin to see how, for the last 100 years, the winds came out of the north the third week of September. Or for the last 100 years, the temperatures were highest in this month or that month. And the structure of that data was very primitive, and it was difficult to access, but it was precious because it was predictive, and that's what's going to happen again. Our ability to move data is already exponentially. What are you going to do to make that thing go? All right, our ability to move data is already just exponentially improved, and it's getting faster by the minute. The computational power that we're seeing, the amount of sensors that are gathering the data. I want to introduce you to this young man. This is Pranjit. In May, he was one of 20 university students who submitted a project to the TRA. Joydeep gets credit for this, Joydeep. And what they did was they studied what it took to eliminate pests 100 years ago. And you know what they did? They dug trenches, they put neem grass and offensive smelling stuff in it, and the bugs left town because they picked the right time of day and the right time, the right wind, and the bugs left town. So what these guys do is they've got hyperspectral eyes on the front of the drone. It scans the whole farm. It finds that there's an infestation at a certain location, and then it goes over there with a smoke box and generates a large amount of smoke, which the propellers drive down into the farm. And when it rises, the bugs leave. So we gave those kids first prize. It was such a cool mix of ancient, non-offensive techniques. It's a little hard on the atmosphere, but not the worst thing you've ever seen. And these are 23-year-olds. They see data differently than we do. They see masses of data. The second prize winner was a group who amassed so much information about rainfall in Assam and all of the cycles and all of the stuff that those meteorologists were doing in 100 BC. They put all of that inside of a simple app, and a person who's looking at a conventional weather station can touch that app and see what kind of problems can ensue. For example, pests under certain circumstances need a certain amount of humidity in the air, or you have problems with drought. You have other aspects of that, all of which can be predictive. I'm going to use that word several times because it is possible for us now, as you see here on the right-hand side, for us to look at a field from hundreds of feet above it and see the actual contours of where the water's necessary and how badly, the plants are faring on a daily basis. At the top, you've got, weather equipment. It allows you to have a sense of situational awareness. You can be a farmer and sort of intuitively know what's happening. The weather's changing, the temperatures are high or low. But it's quite amazing to be able to say, here's how many gallons we're going to need to expend in order to produce the water we need for irrigating 1,200 hectares at a certain location without overusing the water or not. This little device is actually It's working now. Okay, great. This little device is just a few $100s, and the technique is labor saving because instead of having a bunch of people walk through the field, this machine quickly identifies where there's a problem, and however they rectify it, if it's a simple problem and they use the smoke, that's great, but there's also 100 other interventions that you can use once you become aware of the problem. So my point is, sensors are going to be big, and look at these numbers. 4.1 billion going to 41 billion. And this is just agriculture sensors. I'm not talking about all the sensors in automobiles and all the rest of that kind of stuff. You're going to see the entire world of agriculture utilize sensors. How many in a farm situation are using sensors right now? Somebody raised their hand because I'm surprised if I didn't see several, right? You're going to be using sensors very quickly. I'm looking at you, Matthew. It's going to be really helpful to know what's happening in remote portions of your KDHP. And, you know, these machines are so efficient that you can inexpensively, they're a couple $100, supply their Internet of Things, they supply the information. So here's the other thing that's going to happen. That's applied AI. That's the kind of AI that has to deal with structured data. Carthy, you know how structured data works. It's messy to work with unstructured data, but structured data is very predictable, inexpensive to design the queries, and a great solution. So I keep pushing this button, but I don't see anything happening. Up there? All right. The second kind of applied AI that's really going to make a difference to the industry is automation. Now, you're much more familiar with that. And you're looking at new forms of automation. This device here just strikes me as amazing. That's a 360-degree rotating panning device. It's useless without a human being because it's a tool. But a person, if you've ever panned, a person puts their hands in the leaves and rolls them and moves them. Not necessarily uniformly, scorched my hands whenever I do it, and small quantities. This does hundreds of kilos, and do you know how they know if the tea is ready? Just like in the old days. He reaches in and smells it and says, this is a batch that's ready to move to the next stage of production. So machines like these, automated transplanting devices, ensure that the plants are all in the exact correct depth inside of the nursery. Devices like harvesters are all going to elevate labor, not eliminate it. There's a lot of conversations about how everything's going to, take down labor and avoid. What we're doing is we're elevating labor. We're making it more possible for people to do more meaningful work. And look at the numbers here, too. This is just in harvesters. You're going to see just a revolution here because it's no longer cost-effective to hand-pick a lot of stuff. It's very useful to pick it and have electronic sorters sort it into 3 piles and make your tea from there. Match marketing. This is generative AI. This is using disparate data from lots of different locations to try to ascertain where your market is. And it's useful for advanced blending, it's useful for personalization. And something I think one of us should do is to lay down a map in Sri Lanka and show where the current destinations are, where the port of entry and port of departure for all major tea, and then use a Google search, a trend search, to find out where people are talking about Ceylon tea. And any place that's not normal, meaning not where you normally unload your product, that's an emerging market. You're going to make some money going to that emerging market. So, we've got too much. We need to rethink about where we're putting it, how we're selling it. We need to, in my view, increase demand, not try to regulate those who are growing the tea. And that is my introduction with 27 seconds to spare. So we're bringing our speakers up to join us. Alan